Welcome everybody to the Business Agility and Leadership Meetup. This is our sixth one, I think, Kareem, if I remember rightly. And today we're hosting Joe Justice, inventor of a whole heap of different things, actually. And I'll let Joe actually introduce himself because he's been doing this for quite some time and is well versed in speaking. He's got a talk tonight around agile hardware, where he's going to explore some of the interesting things he's seen using and applying agile techniques when with robots and with jet fighters and all kinds of weird and wonderful things. So he's going to explain all of that as we go through. I'll be capturing questions in the chat in Zoom, and there'll be a 10-minute session at the end for us to do a bit of a Q&A directly with Joe. There will be a recording of this available tomorrow, and we'll ship it onto YouTube. So without further ado, Joe, over to you.
John, thank you so much. I hope everyone here knows John Spruce very well. I'm familiar with John from his work globally with Agile transformation and also working with high tech, with drones, jet fighters, that type of work, which is a space that I work in as well. So for those of you who aren't intimate with John Spruce's work, not only do I recommend it, I'm inspired by it. Please do mind him as an England-based resource who works globally. I'm Joe Justice. I'm the author of the Scrum Hardware Guide. I wrote the foreword to the book Scrum for Hardware, which is by Paolo Samichelli, and I highly recommend that book. The second half of the book are technical practices to actually do this stuff. The first half of the book, I'd say embarrassingly, is the story of how Paolo and I met. So some people may want to know that, but I will say, out of shyness, please skip to the second half of the book, which is the technical practices. Let me get the slide share shared here. Okay, now I'll ask, are attendees able to see my screen? Do they see this thing that says Agile Hardware? Okay, good. The reason why I think this conversation is worth having with this group, oh, it's auto-animating. That's not what I anticipated, is because there's so much money for companies in agility. Now, what I personally love about agility is the respect for people, the cross-functional teams, the humanistic approach, the customer-centered design, so we have higher customer satisfaction. That's what I really care about. However, I run a business helping companies succeed with agility. That means I need to focus on the business value. So what I love about Agile are the human aspects, the work worth doing, the respect for people, the human-centered design. From a business perspective, what I'm going to talk about is how to make money with Agile. And it certainly looks like the way to do that in hardware is faster new product development, NPD, and faster new product introduction, NPI. NPD plus NPI, the rate at which that happens is directly correlated to total stock value. You can see it here. These are some real companies, and these are their real stock values in recent times. I think I mined these numbers 10 days ago. At the top, you see Tesla. And Tesla is trending to be one of the highest market capitalization companies of all time. And they have the fastest new product introduction rate of any company in their space. You can see the ratio is coupled. You can see the correlation. Tesla does 27 changes or more, but publicly they'll say 27 changes in new product development or new product introduction a day. So the Model S luxury sedan changes in hardware more than 27 times a day on the line. And you can compare that to the other companies listed below and see the correlation with their stock price. So for business value of agility, what I'm talking about in hardware agility is faster NPD and NPI. That's it. That's the name of the game. Interestingly, the way we do that is what Agilists are familiar with. Cross-functional teams, customer in the loop, customer as product owner. It's the humanistic elements that actually make that come true. And heavy automation, excellent DevOps. And DevOps in a factory is still automated test and deployment, but it's actual physical robots instead of scripts. And I'll try to show you what that is. The reason I'm familiar with this is I was just recently working at Tesla during their largest stock price ramp of all time. I operated Agile at Tesla while I was there from the global headquarters in Fremont, California. Before that, I'd been in this space working with jet fighters, et cetera, and you'll see some of that and what I learned there. Executives get it. They get that the rate of change is the factor you want. Here are a set of my clients. I've worked directly with these people. First, Volkmar Denner, chair and CEO of Bosch. That's more than 300,000 employees globally. And Volkmar says, for Bosch, agility is crucial. It allows us to adjust to the increasing speed of change around us. Agility allows us to remain in a position as an innovation leader. Akio Toyoda, the CEO of Toyota, sent his son, the next CEO of Toyota, Daisuke Toyoda, to take my class and be trained by me in Agile hardware. And the entire Toyota Advanced Research Group, TRIAD, was all trained in Agile hardware. They all received their certified Scrum Master certificate, and I myself trained the majority of them. And he says, when you look at a product going to the actual sites, going to Genba, the place the work happens, not just the place the work is planned, what is important is to fuel the change point. So he's saying what's important is faster change. Herbert Dice, CEO of Volkswagen Group, my partner, works directly with the board of Volkswagen. The big question is, are we fast enough? If we continue at our current speed, it's going to be very tough. And then finally, where I worked directly with Elon Musk, pace of innovation is all that matters in the long run. The common thread here is the top executives get it. They're saying agility is speed. That's why we want it. And from a business perspective, I agree. That seems to be completely true. Public-private partnerships the world over are agile. US Department of Defense, Australian Department of Defense, Lockheed Martin, Raytheon, Google, Amazon, Microsoft, Boeing, Hewlett-Packard, Tesla, Toyota, MIT, MIT Sloan Business School, Siemens, and more than 100 others are all places I've taught Scrum or consulted. The majority of the world's public-private institutions have some type of Agile initiative in progress or are undergoing a full transformation right now. The majority of the world's currency is undergoing an Agile transformation right now. This is not new stuff. RBC Bank, 7,800 employees, Canadian 660.9 billion assets under management. ING Bank, 887 billion euro assets under management, 5,400,000 employees. Pictet Bank, the largest privately held bank in the world in Switzerland, Swiss francs, 544 billion assets under management. Capital One, US, 372.5 billion assets under management, 48,200 employees. All of these organizations have Agile initiatives, or Agile is their core way of working. This is not new stuff. We're not at the initial ramp. The majority of the world's currency is part of an Agile transformation or fully Agile management. In hardware, what this stuff actually looks like, the best I'm learning, is a lot like what Henrik Nieberg said Spotify was doing years ago. And many people call this the Spotify model. Henrik himself says, no, there's no such thing as the Spotify model. There's only what Spotify was doing at the time, and what Spotify is doing now is actually really different. In any case, what seems to happen is the product, in this case hardware, is split into modules. So you have a battery pack, you have the electric drivetrain, you have the crash absorption structures, you have the interior as a module set, etc. You have modules. They're made loosely coupled so you can develop them in parallel. Then independent teams own each of those modules so they can all develop at the same time. Each of those teams has someone to prioritize. I'll call that a product owner. They have people to remove impediments. I'll call those Scrum Masters. And they have all the development skills they need to get their module done as if they're their own company. So they have their own procurement, they have their own financial oversight, they have their own spend authority. They're like independent companies. This is very similar to what Henrik Nieberg showed us Spotify was learning years ago. This is almost identical to what my best friend Paul Tacken rolled out as the lead Agile coach at ING Bank. Personally, I haven't had need yet for tribes and guilds, but communities of practice and quality circles have helped me tremendously in Agile hardware because you have test skill on every team instead of a separate test organization. So how do they all share emergent excellent practices in test? Well, they meet cross-team in communities of practice or quality circles to keep each other up to date. This is in hardware what many people are referring to as the WikiSpeed model, which I prototyped in 2006 in my own automotive manufacturing company. Regulators are getting on board with this. In the United States, medical devices for human medical use, like surgically embedded heart monitors, this type of thing, like Neuralink, need to meet FDA, Food and Drug Administration approval. The top of this slide is the actual graphic the FDA publishes to say, here's how to get your product approved for implant into a human body, whether it's a hardware with embedded software and an app to manage it, or if it's medicine. And this graph is a waterfall graph. Well, under this, in the FDA law, they say waterfall is actually only appropriate for the most simple, the most trivial medical applications. They say for more useful medical applications, you need concurrent design, development, and test. That starts to sound more like Agile, right? And they say you need a feedback loop and iterate. That starts to sound exactly like Agile, right? And then they say the device approval file, the document that says what process you used to get your device tested. They said the primary consumer of that document is you, the company that makes the device. It's not the FDA. So they're saying, don't blame us for not being Agile. They're saying you need to do concurrent development with design, test, and engineering simultaneously. You need iterative feedback loops unless you're making a trivial device. And how you say the process you say you use, yes, we require you to write down the process you used, but that document is primarily for you. It's not for us. So the FDA is saying, get Agile. And that's one of the larger governing bodies. So even the policymakers are saying, we want faster deployment of meaningful, exciting, new breakthrough technology. And to do that, you can't use waterfall. And that's written directly in the law. That's happening more and more. I'd like to show what this really looks like. Here's Volkmar Denner, chair and CEO of Bosch. And you saw this quotation from Volkmar previously. Here's how they got started. Step one, Volkmar called my mobile phone and I was starstruck. That was amazing. Thank you so much, Volkmar Denner and the board of Bosch. I was then brought to work directly with Volkmar one-on-one, consulting on agility at Bosch in hardware and agility in general. Then Volkmar had me give a keynote to all of Bosch leadership to get them excited and informed of what Agile could mean to Bosch. Now Bosch is a huge company, 300,000 employees. So the top leadership team at Bosch is 500 people. So that was a keynote for 500 people and their significant others at a gala style event, a beautiful dinner. Then I did small group sessions with all of the executives. Step three, I worked with the product teams. On the left-hand side of this slide, you see the sprint review of sprint one of one of these product teams. That's a Bosch rangefinder device attached to the front of a freight train, a freight locomotive. It's to give feedback to help prevent collisions of freight locomotives. The point I'd like to make is in 1 week, in sprint one, there was a device actually in the field being used by a customer. Real Agile, right? So these sprints end with hardware, with software on them being used by the customer. Here are the next 4 sprints for 5 sprints total. This team at Bosch had a sensor array put inside an enclosure to detect physical objects near the train, out of the line of sight of the cab engineer, the engineer in the cab of the train. And they had occlusions from weather. They put a windshield wiper on and they tested it on real trains. In the next sprint, the next week, they had a different sensor arrangement, a different circuit board, different embedded software trying to interpret the sensor's input, and they had a different shaped screen and a different wiper. In sprint 3, they had made their own enclosure by now with a new circuit board that they'd made, new embedded software that they'd made, different sensor array, and a different wiper assembly. By sprint 5, the software was so good, it could interpolate the sensor feedback to compensate for the enclosure, and they no longer needed a screen and a wiper. It was now good enough that it could go on sale. So this is 5 one-week sprints, each sprint delivering working hardware and software with circuits, with enclosures, tested by the customer in the field. So this is Agile hardware. It's faster new product development and new product introduction. So the NPD and NPI process in this case is weekly. Here's what it looks like in mass manufacturing. This is a picture from Tesla. I am not allowed to share pictures from Tesla unless Elon Musk shared them or they've been approved by the Tesla leadership. Elon Musk shared this picture. So I've marked it up to show you what's going on here. When you have new hardware being deployed continuously, in Tesla 27 times or more a day, how that works is robots do your continuous integration. So this is a build server in hardware. This is DevOps. This is what DevOps looks like in hardware. This is continuous test and deploy. The robots, because you want it automated, right? Just like software. The robots have flexible hands so they can hold different parts because they're given different parts 27 or more times a day. So the robots need to be programmed continuously how to hold the new parts, or now there's a lot of self-programming. The robots then hold parts that have known stable interfaces. You can see in orange circled the mating points between the parts. Now, as long as the mating points, the interface doesn't change between parts, any other area of the part can change at any time, and they'll still successfully mate. Now, the interface itself can also change at any time, but the development teams running in parallel need to agree when the interface changes. They need to sync up that change. So they both need to agree, this release, the interface changes on both parts, or maybe even more than 2 parts. So the interface changes simultaneously so it stays in sync. With that, you have continuous release in hardware. And at the bottom left, there's a picture of me at Tesla's global headquarters in Fremont, California as an employee. Here's a tweet that I think sums up the value and the mindset that makes this work. Automation in software and hardware and management with test in the loop is in fact the answer. Humans are for creative problem solving. Automation is for everything else. If we look top down at a factory when it's getting new product continuously, the previous model is not efficient. The previous model is what we called lean single one-piece continuous flow. The Toyota production system is famous for this. That model, if you're looking down on a factory, is where trucks unload supply, stock, and it flows through operations at approximately the same speed. And then it is with integration from one step to the next continuously. And then it's taken to a test center and then deployed. Well, the problem with this is when you introduce a design change, it disrupts every step in the flow, or it potentially disrupts every step in the flow. This makes change very expensive. It makes making the same thing efficient, but it disincents change. It says, we're going to spend a lot of money if we change, so don't do it. This encourages a long lead new product development, new product introduction cycle, where you try to get it perfect before you deploy to production. But then that means you delay getting feedback from production manufacturing, which would in fact feedback to change the design. So overall, we have the slowest possible deployment cycle. The case I'm going to make is that single one-piece continuous flow is completely inappropriate if you want speed of change. If you want speed of change, we do something entirely different. It's called massively parallel concurrent manufacturing. What you do is stock is very wide. We call it a stock backplane. The stock backplane is then accessible by everyone in the factory at the same time. And you have humans pushing carts or autonomous carts delivering whatever you need wherever you need it. This is less efficient. But what we're aiming for is maximum overall efficiency, including change. And I'll try to explain. So you don't have a line. There's no single one-piece continuous flow at all. Instead, you have a stock backplane and you have goods crisscrossing towards the lean cells, the production spots. The production spots are making new hardware, different hardware, up to 27 times a day. So they pull different stock continuously. What they're getting, it changes 27 or more times a day. Then they have to do their own testing of their subassembly or their module, because change is so frequent, you can't test 1 out of every 1,000 parts, which would be a traditional method. Instead, you have to test every part. For that to scale, test has to be automated, which is exactly what we do in software. You have full automated test at the point of manufacture, at the build server tests, right? Just like we do in software. So the build server here is physically making things, and we do automated test. So each of these units, these modules, they do unit tests. Well, they don't get to call it done unless it integrates. So just in front of these teams, you have the integration area, which is massive. And that's the stock front plane. Out of all these units, all these modules, they don't get to call their work done unless it fastens, unless it connects to the next step. And the software tests pass, the physical tests pass, the torsional tests pass. Now you have an integrated product. Every single one passes integration testing before it leaves the hands of the unit teams. You don't need an offsite test center then. The front plane also includes final integration test, and you ship directly. So what I'd recommend is taking that building that used to be used for integration testing, because now integration testing happens right in front of the unit teams, the module teams, and give back to the community. And we see more and more of these high-tech agile manufacturing operations have schools for the community baked right in. For example, at Tesla, there's an arguably top school less than 2 kilometers from the headquarters in space that previously would have been acquired by the company and used for stock holding or testing. So you have an opportunity to give back to the community. For details on all of this, because I'm giving a short overview, please read the book by Paolo Samichelli, Scrum for Hardware. The second half of the book are the technical practices that actually make this work. This works in construction as well. In the United States, building a hospital took months. Well, it took many years, many years. During COVID-19's peak, there were mandates to acquire new hospitals with new beds in 3 weeks. And companies did it. So how they did it is completely parallel. It's the same. The companies built modules, and the modules weren't separated by function. Each module has heating, ventilation, air conditioning, air scrubbing. Each module has active hospital beds. Each module is a complete miniature hospital. Now they can connect. So the more of these you put next to each other or on top of each other, the more hospital bed space you have. Companies designed, analyzed, built, tests, and deployed these hospitals in less than 3 weeks, in 3-week sprints. Now to make that fast to deploy, the maximum size of the envelope is the maximum road legal size, in this case, in the United States. So that's 8.5 feet by 14 feet tall by 40 feet long, or in some cases a little bit longer and a little bit wider, depending on the variances allowed and the bridge access. So you have modules that are the maximum size, the interface size that meets your transit, and you build to that interface. Then you build out those modules in mass, changing every time, where every one is improvement of the last, but the interfaces stay the same. And this works, so you see it in construction. That's of course how these factories are being built. This is the Tesla Gigafactory in Sparks, Nevada. This is using what's called modular XY construction. You can see the XY axis is a repeated interface. Now what's inside these modules is best in breed at the time it's built. So what's inside gets better every time these are built, and they're built sequentially. From the moment the first one is built, there's work happening inside, production. So these are online with employees as soon as there's an enclosure. In fact, in all honesty, there's work inside these, production work, before they're finished, before there's even a roof. Right now, if you look at aerial photography right now, in the squares where you can see the building's not done, right? They're building more squares. It's not filled into the overall shape yet. And there's full operations in all other cells. Well, there's even operations in the future spaces that aren't built yet. It's tents. So first you start with a tent in the desert and you build, like full on, full scale, 24-hour operation build and test and design there. And there's remote design too. And then the building gets built up around you, which allows you to have a cleaner operating environment, allows speed to go up, allows production density to go up. And you continue operations as you build the next. So this is modular XY construction, which allows the fastest time to manufacturing. Well, in the inset picture, you can see what's called modular Z construction. And this is an operating building. This is an operating, there's no separation of office buildings and factories in these companies. Like, it's the point of work and everything happens there all the time. Well, there's a new building being built on top while everyone's at work in the building underneath. And this is normal. If you zoom out from this picture, and you can go online, I can't show you pictures of this, but they're published, they're public. There's a tent city all around this where more manufacturing operations are happening, staging and deployment. It's so fast. I don't know if people understand it. When someone says, let's do X, you are doing X within 10 minutes. And yes, it's going to turn into a factory, because obviously that is going to be a better way to manufacture, but there's just zero delay. I had a very enjoyable conversation with Peter Stevens in Zurich on this topic, and we were talking about exchanging flexibility and predictability is a false dichotomy now. You get both with stable interfaces. And Peter and I have an executive class about this in October. So folks who want to lead an agile transformation in hardware or other can enjoy that class with Peter and I on European time. I've had a chance to do this with the F-35 Joint Strike Fighter, the F-22 Joint Strike Fighter, and in Europe, the Saab Gripen. What enables this, here's the head of software for the Saab Gripen Joint Strike Fighter, multi-role Joint Strike Fighter. What enables this is getting permission that your in-house tests count as final deployment tests. Because if you finish your product version and you have an 18-month approval process, that means your shortest sprint possible is 18 months before it's actually done and deployed, right? So to make this fast, Saab works on 3-week sprints. So to deploy new planes on 3-week sprints, they negotiated permission with their aircraft authority to have their internal tests count as final certification tests. So the plane is essentially flyable. Well, it's essentially certified. It is flyable, legally allowed to be flyable every 3 weeks. And they can deploy new software and hardware to the plane at any time. Now, the reason to make that responsible is they do full certification testing every 3 weeks internally. So your test effort does increase in this method. Yes, that's an additional cost. In exchange, you get faster NPD and NPI, and it makes your company more money, which is the first slide I showed. And executives get this. All the executives want this. As a result, you now have fast deployments of planes. You have a fast iteration cycle. And now all the other agile practices make sense in hardware too, like customers in the loop. It makes sense to have 8 pilots full-time on staff if you're making new planes every 3 weeks. The product changes fast enough that real-time feedback is meaningful. And this is happening in commercial and cargo as well. I've had a chance to work with Boeing on their new model aircraft and Mitsubishi on their regional jet. How this happens is, first, there's a survey of all hands, the people actually doing the engineering, the manufacturing, the design, the test, to say, how are you actually working in your own words from your own perspective? Now we have the current state of the company in the words of the people doing the work. That is brought into an executive session to say, here's how the people doing the work say they're doing their work. Here's the gap between that and agility. Agility across the entire company. The procurement, like Mirko Kleiner teaches with Lean Agile procurement, like the hardware, which is what I advocate with extreme manufacturing, across the management, which is what most of us know as agility in management. Here's the gap between fast NPI and fast NPD and what people say they're doing now. That creates a backlog of the agile transformation. Now we know exactly what to do to close that gap and create fast NPI and fast NPD, which is what I'll call agile hardware. Everyone in the company is then trained in how to play the game of agile hardware or agile business. And for me, that is a certified Scrum Master class. I do teach that differently than anyone I know because it assumes the entire company is doing it and it assumes all the hardware is doing it. And this includes extreme manufacturing. So everyone goes through a certified Scrum Master class and then a certified Scrum Product Owner class, the way I teach them. And the result is everyone in the company is on a team, a cross-functional team, and they have a Scrum board. So I know what they're working on. I know what they're working on now, what's done, what's blocked, what's happening next, who's currently prioritizing for the team, who's currently removing impediments for the team. Now I have the known stable interface to work company at a time. Those are all combined onto what's called a group scrum board. There's a row for every team, and it says how much money each team is spending a sprint. So I have all up real-time financials of the company. This is also what's called an obeya board in Japanese for lean team. This is a simple obeya room, but it's with group scrum, so it's even simpler. So I know how much money each team's making, and if the team deploys at the end of the sprint, like they do at Tesla, cars are sold continuously, we know how much that team is tracked to making. So I have a cost efficiency of that team. Then there's what they're working on now and their rates of completion and their rate of defect. So I know which teams are fast, which teams are slow, and which teams need help. For all teams, every single human in the company and all the robots too, but that's another conversation, are on these teams with these boards, and each row is one of these teams. There's a column for every sprint, so you can see as far back as you want the board to go, and with virtual digital boards, it scrolls back forever, what the trend is for these teams. Then we have a group scrum daily. The development team members focus on quality and engineering practices. What do we need to change in our engineering practices to have higher quality? The scrum masters focus on speed. And for this, I ask them to use all of lean practices, all of Lean Sigma, all of Lean Six Sigma, all of Toyota Production System, to say, how are we going to increase speed through our unit, our module? And the person's prioritizing by business value, they're continually reevaluating, are we actually building the absolute highest value thing for our group? Now, this conversation makes a lot of sense if you're changing your product every day, 27 or more times a day like Tesla. So if you have real agile hardware, it makes sense several times a day to be saying, do we change to the new product? Is that going to be business value ahead for the company? If you're in a slow company that you're just saying agile words and you actually change NPI and NPD once a year or more, it makes no sense to have a daily conversation, are we building the right thing? Because it would take you longer than a year to change anyway. So this is what happens when you have actual agile hardware, actual fast NPI and NPD. This is a 3-minute conversation. It happens multiple times an hour if your company is fast enough. Again, what it actually looks like is you have module teams. The teams are like independent companies. They have their own financial oversight. They have their own testing. They have their own certification. They have a definition of ready for when they get new ideas. They have a definition of done. That's their quality bar when they're done. And they must abide by that or there's known penalties. All these module teams operate as if they're their own companies. Then there are company as a service teams, this is a common model across Silicon Valley and becoming more common globally, where you have a funding team that continues to provide investment that all the other teams draw from. You have a food team to make sure there's hot, hopefully best in world food every 3 to 4 hours, 24 hours a day, because these are all 24-hour operations. You have a facilities team to make sure the buildings are being built according to excellent modular architecture as fast as possible, security is adequate, the internet is always on, et cetera, et cetera. And you have a coffee team. I'm not kidding about this at all. I've never seen one of these fast companies without this. These are human baristas and baristos 24/7 to mix whatever coffee drink you want, trying to make it best in the world quality. They'll do latte art, they'll do 3D printing foam. I've never seen any of these companies this fast without it. This then is something that is now named after me. Justice is law. And I'm really proud of this. It's an adaptation of Conway's law from the 60s. Justice is law is the modules of the system define the structure of the organization. Or maybe more concretely, the modules of the product define the structure of the company. And by that, I mean, you don't have an engineering group split into mechanical engineering and electronics engineering. You don't have that. It's too slow. You don't have a separate software group. You don't have a separate embedded software group. Instead, you have module groups that include all those skills, cross-functional teams. This is absolutely what a new product engineering team is always said to be. Actually doing it is what increases the speed of NPI and NPD. To do this, we split big projects into small projects and extra small projects. I mean that's it. You split big projects into modules with known stable interfaces. That splitting means these projects can be executed at the same time in parallel because they have known stable interfaces. They're not dependent on each other. The interface is, but the contents inside the interface, the module itself, can be built at the same time. And that's exactly what companies like SpaceX do. Here's the Falcon Heavy landing. This is a sprint review. This is a sprint review of the Falcon Heavy where its booster cores and center cores are landing. And here's a picture of me at SpaceX global headquarters in Hawthorne, California. The Falcon Heavy rocket is huge. It's the highest payload active rocket on the planet. And it's less costly and more efficient than any other rocket on the planet. Well, how do they do that? The Falcon Heavy, an extra large project, is split into 3 large projects, the booster cores and the center core. Those each have 9 Merlin engines inside them. So you have 27 Merlin engines, which for SpaceX is a small project. They make Merlin engines every week. And Elon Musk has famously said they've never made 2 Merlin engines the same. It's a constant NPI NPD. Every single one is better than the last or trying something different than the last forever. So you have 27 of those, which for them is just normal operations. They make them every week and they're improved every week. And once you have 27, those are assembled into 3 Falcon 9 rockets. And those 3 Falcon 9 rockets are assembled into a Falcon Heavy. So it's taking an extra large project and splitting it to smaller, extra small projects. And the reason why that's a good idea is what the Standish Group has been telling us since 1985. The Standish Group tracks software, hardware, finance, real estate, and other project types all around the world. They've been doing this since 1985. And what they've told the world, is that large, big planning upfront projects, they call that waterfall, where the project is planned once up front and it releases once at the end. Large, big planning upfront projects have the highest failure rate of any type of project. They're the highest risk. More than half of them are complete and total failure. Sorry, 42% of them are complete and total failures. Nothing is ever shipped. All the money is spent. Small, agile projects that are delivered as extra small projects continuously have the highest success rate of any project type. They have the highest, that 58% of them are on time, on budget. This is why, this is the actual risk reduction. So to demystify all this agile stuff, the risk reduction is you make extra small projects. Like that's it, that's the risk reduction. So how do you make it very efficient to make extra small projects? And now all the other stuff that I've been trying to communicate makes sense. That's what enables us to make extra small projects. Now, each of these extra small projects is getting done in a very short amount of time, usually less than a week. At a company like Tesla, there's more than 27 of them finishing every day. So you can easily have a burn down chart showing when each of these are going to be done. So the burn down or burn up charts that many of us Agilists are used to now make perfect sense in hardware. And this is not burn down to planning being done or test mule being done or functional prototype being done. This is burning down to deployed in the manufacturing line because it's happening more than 27 times a day. So you have these short, extra small projects that aggregate, completely transform entire projects. So you have massive change as well, but as an aggregate of many small change. And we track those using burn down charts. What makes this fast is each of these module teams focuses on only one module at a time. They have cross-learning through communities of practice and quality circles, but they do one project at a time to avoid multitasking. You don't have a mechanical engineering group that's getting requests from many different projects. It's too slow. Instead, each module team has its own mechanical engineering staff, focusing only on that one module for that sprint. What that does is project A is 500% faster, project B is 250% faster, project C is 167% faster than working on project A, B, and C simultaneously. This was coined as a rule of thumb by Gerald Weinberg. I then did 6 years of field research with 3,500 business professionals while they were actively working on real work. and found these numbers. So this is the result of field trials from all over the world: Europe, the United States, Asia, South America, Africa, etc. This is exactly what actually happens in real offices according to the 6-year study that I conducted. And here's what it looks like. Here's a Scrum Room for the Saab Gripen. You have a cross-functional team. Robots do the assembly. Humans do all the creative thinking. And it's continuous integration. So there's never an idea that's not then put directly on the plane to see if it really works. I mean, you don't just do mechanical engineering. You don't just do software engineering. You're a team that works on the Gripen, and you deploy stuff to the plane. And that's more exciting. In Sweden, where this happens, in Linköping, Sweden, where this Scrum Room is, this company is the #2 place to work, chosen by all graduating engineers, because they actually get to work on planes, not just abstract projects that somehow get involved in a plane and they're not sure how. There's a picture of me in the inset with the author of Scrum at Hardware by Paolo Samachelli, and the lead executive of structures, the interface of how all these modules connect. That's Jürgen Fulhelm at Saab Aerospace, Saab Defense. Here is the book Scrum for Hardware. I didn't write it. I highly recommend it. Humbly, I'll say skip the first half, read the technical second half. You can read the free sample at the URL below. I'll ask John Spruce and team to distribute this to all attendees and to post it on their site. I recommend reading page 13 and 14 tonight, 2 pages. That is my request of you, to read these 2 pages. I think it will cement many of these thoughts. Please take a screenshot right now, or even use your phone and take a picture so you can remember this and you have the URL, and I'll ask John to share it as well. I'll advance the slide in 3, 2, 1. There's Agile hardware training in Europe now. I do not do this. I make no money from this. I recommend it. Marit Lantil puts this on from Finland, from Helsinki. And I saw the course contents. She walked me through the course. I think it's exactly right. Now, she told me something very bluntly, and I completely agree. She said, Joe, what you do, more than 27 deployments in hardware and software a day, is so far out of the mental understanding of most existing companies. What you need is a stepping stone plan that brings you towards there. And I said, Marit, I don't know how to do that. I only know how to actually do this. And she said, okay, Joe, I get it. Please keep doing that. What I want to do is show you a course that takes big old companies from where they are now to what you do. And I said, Marit, do it. And she nailed it. It's, as far as I can tell, exactly right. So this is how to take a great big slow monolith to become this nimble, awesome, agile company. Because I'm not sure I actually know how to do that bridge. I'm already there, and I don't want to stop being where I am. I'm afraid I'll forget how. So come talk to me if you want to be inspired, or if you want radical executive-led transformation. But if you're a mid-manager somewhere in the mechanical engineering group, because you still have groups split by skill, take this class instead. I don't make any money from it. I think it's the right thing to do. It's your stepping stone. It's basically your scaled agile framework to be a Band-Aid from a company that's going to die if you don't change to a company that's on a path to continuous improvement. But then when you're ready to actually become a Tesla, come talk to me and we'll restructure the company again. What I actually do is restructure companies with the board of advisors, because that's what you have to do this. You're blowing up the separations between mechanical engineering, software engineering, anything like that. And you have actual project teams across the entire company supported by company as a service team. I'm Joe Justice. I operated Agile at Tesla. I've guest lectured at MIT Sloan Business School, Oxford University in England. I'm the author of the Scrum Hardware Guide. I'm currently the chair of the Agile Business Institute. I've been interviewed by mainstream media all around the world. The Discovery Channel did a documentary about me. I've worked with Lockheed Martin, Google, Amazon, Microsoft, most of the banks in the world. I'm in Harvard Business Review about once a quarter. I'm interviewed by Forbes about once a quarter. All of this is to say not, hey, look how cool I am. It's to say, I think I've been vetted. I think this is real. And major publications also seem to think this is real. So maybe you can trust me. And I'd like to work with your board to restructure your company to deploy more than 27 times a day, which is actual agile hardware. The fast NPI, fast NPD is what Agile hardware is. And then on a personal note, because I think I have 2 more minutes, at the bottom right is a picture that many people have asked me to remove. They said it could make people feel uncomfortable. I do apologize for that. That's possible. But I very intentionally kept this picture in. It's a picture of me without my shirt on. And why is that here in a business presentation? I met someone named Maria Mattarelli, who's the lady in the inset there. And she coaches something called personal agility. And she says, Joe, what would happen if you put your personal goals in the backlog and then executed the same agility? It works for your clients, it works in business. What would happen if you put your personal goals in there? And I said, well, let's find out. She said, I will be your personal agility coach. And I said, I want 6-pack abs and I want $1 million in my retirement account. She said, cool. Let's put them in your backlog and I'll be your scrum master, basically, your personal agility coach. And it worked. I got $1 million in my retirement account and 6-pack abs. I mean, whatever your selfish goals are, I'm sorry, it wasn't like feed the world. Maybe I'll try that next. But whatever your personal goals are, it looks like this Agile stuff actually works. And applying it to your personal life is what's called personal agility. And I highly recommend Maria Mattarelli as your coach. She co-authored a book with Peter Stevens, who I earlier mentioned, on the topic, personal agility, and it's awesome. So if you have life goals in your family, your studies, your professional life, your personal life that are important to you, I'd recommend it. It absolutely works. And with that, I'm all done. I'd love to see if there are any questions, and I very much appreciate getting to work with you and share what I'm excited about, what I'm passionate about, and what seems to be completely disrupting the world of hardware right now in terms of new product development speed and new product introduction speed.
Brilliant. Thank you so much, Joe. That was a really interesting talk. And Maria is actually going to be one of our guest speakers in the future as well, so she should be joining us soon. That'll be really cool. We do have a collection of questions that I'm going to just read through. I've enabled people to unmute if they wanted to talk to you directly. There's a few questions here. I'll run through them one by one. We have about 10 minutes until we can get through, so hopefully we can get through all of them. Femi asks, is this adopting a structure similar to the Scrum at Scale framework?
I'd say that's a really good stepping stone, as is LESS, as is the Scaled Agile framework. They're all quite different, actually, but they're all awesome stepping stones depending on the current state of the company. What this ultimately is a little different than all of those. There's no product owner team. It's too slow when you're going this fast. There's no chief product owner. It's too slow if you're going this fast. But that's an awesome stepping stone to get towards this from the structure most companies currently have. It does end up being teams directly communicating with each other in that thing that I didn't have a better name for it. People keep copywriting and trying to make frameworks. So I just called it group Scrum to be agnostic, but it simply is this minimum viable structure of the teams communicating in real time. That is a documented format. So you can learn group Scrum. It's what we do if you take a class from me. But I would recommend all those scaling frameworks as bridges to bring companies towards it. But in the ultimate functionality, it's not any of those named frameworks. They're not quick enough.
Thank you. Thanks for that, Joe. That's really helpful. Ilhan asks, in the case of designing a vehicle from scratch, it's usually 3 years plus and a strict waterfall process is followed. How can this 3 years be agile?
It can't. So we use a very different process. It's a continuous design. It's what I tried to say before. I hope some people get it, right? Because it's so different. It's not taking it's not a 3-year waterfall project. It's instead several hundred small projects. This team is responsible for a new paint technology. And as soon as they're done, it's deployed no matter what the product is. This team is responsible for a different type of frame rail. And as soon as that's done, that frame rail is used regardless of what's being manufactured. This team is making a different battery pack size. And as soon as that's available, it's put in whatever the product is. And those just compound. So there's no withholding to try to get projects in sync. It's continuous deployment of all simultaneously. It's a very agile way of thinking. The problem is it doesn't map to people that are used to the previous way of thinking. So this is what Marit's class does well, is start to evolve the mindset from traditional large project mindset to what I'm talking about here. And this is where the Scaled Agile framework, which I do think is an excellent stepping stone for many companies, as is Scrum at Scale, as is Less, as is several others, does really well, is it starts to break down these massive monolithic projects into smaller projects. But they don't, they still have big room planning and PSIs, which is still too slow to get to 27 releases a day. You never could with those formats. But yeah, it's small projects continuously, forever, 24 hours a day is what it is.
Great stuff. Thank you, Joe. That's really helpful. John asked a question. Isn't in-house testing being certification testing the problem that caused 737 MAX issues?
So Boeing is also a client of mine. And what caused those problems is having awful testing. Not it being in-house, not it being as certification, it was having awful testing. So the challenge there is there was no customer in the loop, which is what's called user acceptance testing. There wasn't any. And you couldn't even make an app without user acceptance testing. Who possibly thought that was a good idea to make planes that way? So you have changes to how you're going to fly the plane being deployed without people who fly planes in that conversation. And like, you wouldn't even build an app that way. So it was awful, irresponsible test practices that killed hundreds of people. It's disgusting. And if you had even elementary agile testing practices, it would have saved hundreds of people's lives. So it's not whether it's in-house or not, or whether it's certification or not. That was just awful testing and complete neglect. So what works is having any level of acceptable testing, which would be automated unit testing, automated integration testing, user acceptance testing, module level testing, business level testing, you know, normal standard testing practice, having that in the loop for every iteration. And the speed at which that happens is what solves the problem. Now, saying what we need to do is have longer testing is a broken way of thinking. It's having good testing, one. And if you don't have good testing, you have catastrophes like what happened. So step one is get good testing, and we know what that is. Then do it faster. And faster means it's in the loop at design and build time.
Great stuff. Thank you very much. Luca asks a few questions. I'm going to pull one of them out here, really. How do you do automatic integration and testing in electronic hardware?
Oh, yeah, cool. So hardware testing, whether it's done fast or slow, for electronics and physical testing, is you pull and push on things, and then you run electricity through contacts, and you do logic tests as well. I mean, that's what it is, right? And those logic tests can be super complicated, or they can be trivial, like, you know, does the ground wire work? But what it is you touch probes to electrically charged areas of the product, and you run logic tests and continuity tests, and you pull and push on things and twist things to do stress, strain, and torsion testing. And that's what it is. That's it. That's the entire envelope of testing. Well, you can do those really fast. You can have robots really quickly connect the continuity probes, and then you can have massive compute power run huge amounts of logic testing and continuity testing in nanoseconds. And at the same time, potentially, you can have manipulators grip hold points and do stress, strain, and flexural testing. You can even do destructive testing on one out of every N. So testing is what I just described, and it can all be fully roboticized. And it can also all be simulated. That's what computational fluid dynamics and finite element analysis is. So you have continuous simulation at design time, and you have continuous physical testing by robots at build and manufacture time. And it just never ends. Then you want faster robots, and you want products designed for test. So they have easy grip, fast grip places. They have easy touch, fast touch contacts. The electronics and the software in them are designed for fast diagnostic, and you test every single piece, often in less than a second.
Wow, that's crazy. Yeah, that timings. And Nixon has got a couple of things here. He said that he saw you rapping with Maria at Agile 100. It's very good. His actual question is, what about ASIL certification? How can you do that, Agile?
So governing bodies are starting to mandate this, like the United States Food and Drug Administration is. They still have waterfall models for people to follow along if people aren't excited to change, but they have riders, waivers, or documented agile pathways for people that want to have concurrent engineering, recursive engineering, iterative engineering, and faster new product development, new product introduction times. Now, to do that, you have to have pieces of certification happening continuously. You can't have continuous test and deploy with certification at the end. So it means you engage with the certification body continuously. I mean, that's what Agile is, right? You have continuous test and deploy. And that's absolutely available by most governing bodies right now. They will, if you request it, or they might even ask you to get engaged with you continuously. That's what Saab did on the Griffin. That's what Tesla does. Tesla builds in Europe now, right? And that's exactly what they're doing. And so that has automotive spice, a spice. It has all the stack of electronics, road legal, physical device certification in it. And they have this pace of deployment. So you can totally do it. You have to work with the governing body for them to be continuously on site with you for continuous certification. Now, companies that don't want to continuously collaborate with their certification body wouldn't be able to do this. All they'd be allowed to do then is test at the end, and they could never get this fast.
Great stuff. Thank you very much, Joe. We've hit time, unfortunately. There were a few extra questions there, but I'm sure that we can share afterwards. Thank you very much for your talk, Joe. It was really great. What was that, sorry?
I'll request that any unanswered questions be tweeted at Agile Center and at me, at Joe Justice, and I'll reply to all of them if they're tweeted at me. And I'll at Agile Center, and I'll at the Meetup group, so everyone can follow and everyone can see.
Great, so thank you so much, Joe. That's really helpful. This will be made available as a recording, and it'll be on YouTube hopefully tomorrow. We'll post into the Meetup group about that, but we'll be announcing the next speaker soon. Thank you so much for that, Joe. It was really nice of you to join us from West Coast America to talk to us in rainy UK at the moment about the amazing Agile hardware work as well. Don't forget, everybody, as well, that we've got, this is a Scrum user group, so you do get SCUs for attending today. If you need any help with that, just get in touch with Agile Center. In the meantime, thank you, Joe. Enjoy the rest of your day, and thank you, everybody else, for joining. That's it. See you next time. Take care. Thank you, Joe.